Okay, dear students, let us now discuss centroids of composite areas. As you can see in this figure 4.14, this is representing a composite area, which is comprising a semicircle, a rectangle, and a triangle. As you can see, the representation or division of this area shown in 4.4, the division is shown in figure 4.15. Okay, so this area is divided into three parts. The first part is a semicircle with area A1, the second part is a rectangle with area A2, and third is a uh, triangle with area A3. As we have already discussed in our previous video that centroid of all these entities like circle, semicircle, rectangle, triangle can easily be interpreted, or they can be easily calculated. For example, for this semicircle, we discussed this in our previous video, and for rectangle it is just the center point of the rectangle, and for triangle it is 1 by third of the height from the base, both in x and y direction. So these things are very well known to us using those formulas. And after the centroid of the whole figure, which we represent as x bar and y bar, x bar in the x direction and y bar in the y direction. So this is found using this equation that we are the explanation of this is given in the three equations that you are seeing in 4.1 before 4.1, that is a1 plus a2 into a3 plus a3 up to an. That means all the divisions that we have in the area into x bar, which is the x location of the composite centered of the composite body or composite area. So this is equal to a1 into x1 plus a2 into x2 plus a3 into x3 and so on up to whatever the number of divisions that you have for this area. Okay, because we already know the position of x1, x2 and all that, we can easily find out the x bar in this case. And similarly for y bar, again the same thing. So this is the formula that we will be using in our next examples. That is, we will individually find the area of a composite figure, and then we will find out the centroid of this individual area in the composite figure, and then we will have the summation of area into the centroids, and that means the x position in this case divided by the total area of all the divisions of this figure. Okay, so this is all about the composite figures or composite areas. Okay, and for solid bodies, we have this again the same thing. Basically, we will have the volume multiplied by the position, that is sum total of the individual volumes into the individual position of the centroid divided by the total volume. The same uh, procedure that we followed for the area identification of centroid for areas, in this case 4.41 and 4.2, sorry, 4.1 and 4.2 equations. Similarly, we can find out the centroid of solid bodies, whether it is comprising of volume, or it is having weight also. That means we are considering the weight per unit volume. Okay, so coming on to the our example. Okay, so let us discuss one example, in this case simple example that we will take. And yeah, okay, so example 4.1, find out the position of the centroid of L sections as shown in the figure 4.20. dividing the composite figure into two areas. So this is the composite figure. So this is a L shaped. So this can be easily divided into two rectangles, as you can see, rectangle 1, which is indicated over here, and rectangle 2. Okay, so all the dimensions are given, and we can easily find out the centroid of the individual rectangles, two rectangles that you are seeing. Now the problem is to find out the centroid of the composite figure. Okay, composite figure means a L shape, total L shape. So we'll find out first the centroids, and calculate ax and ay for each of the figure. For rectangle 1, which is the first rectangle that you are seeing, the height is 16 and this length is 4, so area is 64. The distance, x distance of the centroid is at the center point, which is 4 by 2, which is 2, and center distance from the lower line, that is LL, which is equal to 8. Okay, and this is total. AX is 64 into 128, and AY is 64 into 8, which is 4512. Similarly, for rectangle 2, we have this length, because we have already considered this 4 centimeter in the first figure, so we'll leave this, and rest of the rectangle is 8 long and 4 centimeter height, 8 centimeter and 4 centimeter. So you have 8 into 4 is 32, and its distance from this x position, CG, the position of CG, x position is 4 plus 6, is x is basically the the position here will be, just a minute, because this is 4 centimeter, and yeah, rest of this, because the total length is 8, so this is 4 plus 4, this is 8, and the height will be 2. Okay, so this is x position, this is y position. So again we will find out the area into x and area into 5, and now we will find out the sum total of this ax and sum total of this ay separately, and find out the x position, like the formula that we discussed in equation 4.1 and 4.2. So this is 384 divided by the total area, which is 96, and for this it is 6, so 4 and 6 centimeter. So this is the discussion of this one example. So we'll discuss more examples in the next video. Thank you.